Welcome back, everyone. So today, we're unlocking the secrets of what I like to call the invisible shield. We all see these massive factories processing tons of materials, but the actual documented rules that keep us safe, well, they're usually hidden right in plain sight. So today, we're diving into one of the absolute most critical rule books in the whole industry, the EPA's Performance Specification 4. Okay, let's dive right into this, because this is really the fundamental question here. When we look up at a refinery, we know there are these mechanical eyes looking out of those smokestacks, constantly measuring the exhaust. But how do we actually verify those mechanical eyes are telling the truth? How do we know the machines aren't just, well, lying to us? That is exactly what Performance Specification 4 is designed to figure out.
Here's our roadmap for today's explainer. First, we're looking at the carbon monoxide challenge. Then, scope and applicability. Third, safety first. Fourth, passing the performance test. And finally, we'll wrap up with the final verdict.
Section 1, the Carbon Monoxide Challenge, identifying the threat. This entire regulation is built from the ground up to target a gas you literally can't see, smell, or taste. That target analyte is carbon monoxide, or CO. And what I found really fascinating during this deep dive is that the EPA doesn't just casually mention the gas. No, they legally bind the specification to its official Chemical Abstract Service Registry number, CASNO 630-08-0. Dropping that highly specific identifier really grounds this whole document in technical reality. We aren't just talking about general, vague emissions here. We are zeroing in on one very specific chemical compound that takes some seriously specialized equipment to accurately detect.
Now, we all kind of know about CEMS, right? Continuous Emission Monitoring Systems. But in the context of this specific rulebook, it's super interesting to see how these permanently installed systems are treated. They aren't just pieces of hardware. They're the crucial watchdogs guarding our air quality. They act as our invisible shield in action, reading the air right there at the stationary source, way before it ever has a chance to disperse. But hey, a watchdog is only as good as its training, right? And that brings us to the real core of this explainer.
Section 2, Scope and Applicability, the Lie Detector Test.
It's absolutely crucial to understand what Performance Specification 4 actually is. Honestly, I like to think of it as the ultimate lie detector test for our CEMS watchdogs. The really important point is this exact contrast. PS-4 is specifically for evaluating the acceptability of a carbon monoxide monitor at the time of installation, or, right after. It's the initial test to make 100% sure the equipment actually works the day it goes online. It is explicitly not designed to evaluate the CEMS performance over an extended period of time. For that long-term upkeep, the document states plain as day that the source owner or operator is the one fully responsible to calibrate, maintain, and operate it as the years go on.
Okay, what's really funny here is the display of government efficiency. If you actually read through Performance Specification 4, you'll notice a hilarious amount of the document just casually cross-references an older rule, Performance Specification 2. For the definitions, the equipment and supplies, the reagents, the calculations, data analysis, even the tables and diagrams, the EPA essentially just waves a hand and says, same as PS2. Which, to be fair, makes perfect sense. Why reinvent the wheel when the fundamental testing procedures for calibration drift and relative accuracy have already been perfectly established for other gases?
Section 3. Safety First. Handling the Invisible Threat. Now, it's super easy to look at EPA regulations as just, a bunch of boring paperwork. But there are very real, physical realities at play here. Evaluating these monitors? Definitely not just a desk job. The specification itself includes a pretty stark warning. Testing involves hazardous materials, operations, and equipment. Think about it. Inspectors are climbing up massive smokestacks, dealing with highly pressurized calibration gases, and working in some really intense industrial environments. The EPA makes it crystal clear that it's the user's responsibility to establish strict safety and health practices before they even think about running these tests. And this brilliantly illustrates how the actual testing is conducted safely and accurately. To prove the factory's monitor is actually telling the truth, inspectors use approved reference methods, specifically Method 10, 10A, or 10B. But the absolute key here? It's the timing. The sample collection and analysis are run concurrently. That means the inspector's reference equipment and the factory's CMS are sniffing the exact same exhaust gas at the exact same time. It is literally a direct side-by-side shootout to see if their numbers match up.
I know we're pretty deep in the technical weeds right now, but hey, before we reveal the exact passing grades these machines actually have to hit, if you're enjoying this deep dive into the invisible rules that shape our world, hit that subscribe button. It honestly really helps us keep making these explainers so we can keep decoding all these hidden systems together.
Section 4. Passing the performance test. The final grades.
Okay, so this is the climax of the explainer. The side-by-side shootout is happening, but what are the strict, totally non-negotiable mathematical grades these monitors have to achieve to actually be deemed legally acceptable by the EPA? Well, first, we've got to establish the baseline. The specification tells us that this particular test was developed primarily for systems with span values of 1,000 parts per million by volume of carbon monoxide. So that's the baseline scale we're working with when calibrating the system for these specific industrial facilities.
Now, here is the first failing condition they have to avoid. It's called calibration drift. Over a period of 7 test days, the CEMS calibration absolutely must not drift or deviate from the reference value of the calibration gas by more than 5%. And get this, it has to maintain that extreme accuracy for 6 out of the 7 test days. That's a really fascinating detail, right? Requiring it for 6 out of 7 days actually acknowledges the messy reality of industrial equipment. It allows for one potential anomaly, but it still relentlessly demands consistent overall precision. If it drifts more than 5% from the established span value on multiple days, boom, it fails the lie detector test outright, no exceptions.
Then, we hit them immediately with the second strict grade, relative accuracy. When comparing the factory's monitor to the inspector's reference method, the relative accuracy of the CEMS must be no greater than 10% when calculating using the average reference method value. It literally has to be incredibly close to the inspector's trusted benchmark. And let's see how this builds, because there's actually an even stricter alternative for that relative accuracy test. We just established the 10% rule, which is used when the calculation is based on the average reference method value. But if the calculation is based directly on the applicable emission standard itself, that threshold drops to an incredibly tight 5%. The logic here is honestly brilliant. When you measure against the absolute legal limit rather than a reference average, the EPA tightens the leash way up to ensure you are nowhere near violating the law. The math just leaves absolutely no room for sloppy monitoring.
Section 5. The final verdict. Protecting the air.
By enforcing these strict, concurrent testing methods and demanding those incredibly tight 5% and 10% margins of error, Performance Specification 4 really forms the bedrock of our invisible shield on day 1. But I want to leave you with a final thought to ponder here. As we established earlier, this specification is explicitly not designed to evaluate performance over an extended period of time. It relies on the facility owner to maintain everything after this initial test. So if PS-4 only tests monitors at installation, who's watching the watchers years down the line? It's a giant, complex puzzle of trust, verification, and ongoing regulation. Thanks so much for joining me on this explainer, and I'll catch you in the next one.